Hi students, welcome back. Here we are beginning with the applications of refraction of light. So here we will understand the concept of refraction of light, how it can be used in our day-to-day lives and how it affects our daily lives. Now, let us take one simple example. If you all might have visited a swimming pool tank, okay, तो वहाँ पे हमने अक्सर देखा रहेगा कि जहाँ पे पानी बहुत गहरा होता है जहाँ पे where the water is too deep, okay, over there they put some instructions like the water is very deep, don't dive or something like that. Some precautionary messages put up over there. Why like that? Can you recollect why like that? Because see this, if you look at it like suppose something is written 6 feet deep, okay, वो एक्चुअल में हम उसको अगर देखते हैं तो ऐसा लगता नहीं है कि इट इज 6 feet deep. You feel as if अरे ये तो ज़्यादा डीप है ही नहीं, करेक्ट? So that is what. So what is happening basically over here is the surface, okay, the bottom surface of the tank appears to be raised in the upward direction. Yes, this you all might have experienced this also. If you take a bucket and if you put a coin inside it and if you look at it from an oblique manner, yeah, and then if you see what you feel as if the coin is raised in the upward direction. Okay, so here the concept goes like this: real depth and apparent depth. So real depth is the actual height or the actual depth. Yeah, like let us say वो स्विमिंग पूल का ही स्विमिंग टैंक का ही एग्जांपल लेते हैं. अगर 6 feet डीप बोला है तो 6 feet deep will be the actual height, okay, or the actual depth. Now let us understand what do you mean by apparent depth. Apparent ये word बार बार फिजिक्स में आएगा students. Apparent means something which is illusion kind of, okay. Apparent is a false one, so which you feel like as if. So apparent depth. So see this. So here is my real depth. This is my real depth, that is PQ or whatever we have now. So this is the boundary, this is air, water, and this is the real depth. Now what will happen is, suppose for this particular entire the surface, I will consider one particular point O. So from here, two light rays are going. One light ray goes straight. So since it is going straight without any deviation, it will pass away. No refraction will take place. Now when the ray OB goes, OB strikes the boundary PQ at B. Can you all see this? Now it is entering from denser to rarer medium, so it will bend away from the normal. So as per our normal law. Now if you trace this ray OB in the backward direction, can you see it is meeting at point over here, and that point we have named it as I. Okay, so at this point basically, so when हम लोग obliquely उसको देख रहे हैं तो ये ऐसे लगता है as if this particular object O, that as if this light ray is coming from here and not from here. Are you all understanding this? Very important. हमें ऐसे लगता है कि ये जो लाइट आ रही है और जो हम उसको obliquely जब देख रहे हैं, obliquely means what? At an angle of approximately making an angle of 45 degree. So ऐसे लगता है कि as if the light ray is coming from here, and hence this becomes, so you feel that this entire thing is raised in the upward direction, and when you trace this in the backward direction, यहाँ पे जो image बनती है, that will be a virtual image. Okay, so this will be my real depth and this will be my apparent depth. Okay, okay, let's continue. Over here we have a formula, refractive index of medium with respect to air is real depth upon apparent depth. Now students, please note that in the textbook the derivation for the same is given. Here the derivation I am not going to cover in this video because it will not be asked in the exam as per, so the derivations will not be asked. We'll be covering it in the upcoming future videos of the 11th standard where the derivation can be asked. Okay, so let's not get bothered with the derivation. There is a direct formula mu m. So it is the refractive index of the medium. So in the previous case where we saw the diagram, the air water was there, so it will be the refractive index of water with respect to air. Okay, that will be equal to real depth upon apparent depth. So here we have to just remember the formula. So apparent depth is equals to real depth upon we just transposing it, एंड शिफ्ट मीन्स व्हाट, जैसे मैंने पहले वाले इसमें बोला था कि अगर 6 फीट डीप टैंक है, स्विमिंग टैंक 6 फीट का डीप है और वो ऊपर तक 4 फीट तक अगर हमको दिख रहा है, तो 6 minus 4 will be the 2 feet. So 2 feet will be what? The shift that will take place. Okay, so shift is nothing but real depth minus apparent depth. So shift का और एक formula है real depth into 1 minus 1 upon mu m with respect to air. This again formula also we have to just remember. Now this particular shift, it depends on 3 parameters. First is refractive index, second is thickness of the medium, and third is the wavelength, how they are changing. So this can be asked, factors affecting the shift of a particular medium. So here if the refractive index increases, shift also increases. Thickness, more will be the thickness, more will be the shift. So here that you can see it from the formula also, shift is equal to real depth. So shift is directly dependent on the real depth. So here the thickness is the actual thickness. Yeah, so that will be nothing but my real depth. Okay. And as shift decrease, the shift decreases with increase in the wavelength of the light. So now this we have been seeing from so many parameters, how refractive index and wavelength are inversely proportional with each other. So refractive index of violet is greater than the red, so therefore shift will be greater for violet as compared to the, so that is shift for violet light will be greater than as compared to that for the red light. Okay. So here let us take an example that refractive index of glass with respect to air is 3 by 2. So what do you exactly mean by this? Means the thickness appears 2/3 of its real thickness. ओके, सो एक्चुअली अगर हमने देखेंगे किसी ऑब्जेक्ट को, सपोज ग्लास स्लैब है और ग्लास स्लैब के नीचे हमने कुछ रखा हुआ है, सो वो कितना ऊपर हमें दिखाई देगा, 2/3 ऑफ इट्स रियल थिकनेस. सो वो 2/3 कैसे आता है, देखो, म्यू जी विद रिस्पेक्ट टू एयर इज रियल डेप्थ अपॉन एपरेंट डेप्थ फ्रॉम दिस फॉर्मूला. सो एपरेंट डेप्थ को इधर ले लिया, आर डी अपॉन म्यू जी. सो बट व्हाट इज म्यू जी, द वैल्यू ऑफ म्यू जी इज 3/2. सो 3/2 हमने इधर डाला, बट इसको ये किया तो इट बिकम्स 2/3 ऑफ इट्स रियल डेप्थ. Okay. Okay, continuing with we are going to take the second example here, which mentions that refractive index of water with respect to air is 4/3. Now what it means actually, this kind of questions can be asked in application based questions. Pay attention students. Depth of the pond will appear how much? 3/4 of its real depth. Okay. So apparent depth is again, formula remains same, RD upon mu. So RD upon 4/3. So this comes up 3/4 of the real depth. Now see this, one more small example is given in the textbook. You all might have often observed this whenever you take a beaker and put a pencil inside it, and when you observe it obliquely, that at wherever there is the boundary, okay, where that was pencil or that stick has been put in the water, it appears as if the pencil has been broken, or as if it appears it is bent. Okay, so what is the reason behind that? So see this, now this xp rather, sorry, this is p dash. Okay, so xp is the real length of that rod or the pencil. So now two light rays, when they are starting from here, they will go from water to air, that is the denser medium. Denser to rarer medium. So the two light rays will start and they will bend away from the normal, and then when you trace these light rays in the backward direction, can you see where it is meeting? It is meeting at the point P dash. So this is what we appear, this is what we look at. Okay, so again the same reason again. Okay, so there are further few more applications. Twinkling of stars, sun is seen few minutes before its sunrise. So all these applications, I'm not going to discuss them in much in detail. So these are also the applications of refraction of light. Coin example, if you put a coin in a water and when you look at it obliquely, it also appears raised. Print appears raised. This you all might have seen on office tables. Basically on office tables, if you all see, there are some papers stuck up inside and there is a glass table, a glass sheet kept. Okay, so if you observe, if you put that paper inside and just try to remove it, and if you observe it, you will see that those print, it looks as if they have been raised in the upward direction. Then person's leg appears short in a tank. Whenever, if you look at a person from outside, object placed in the rarer medium when viewed from a denser medium appears to be at a greater distance than its real depth. Very interesting point, dears, pay attention. This can be asked as an application based question, that suppose if the person is there inside the water, that he is he is in a denser medium and he is viewing a plant or something which is in the outside medium. So what will happen when he will look at that person will appear to be at a far much greater distance. This is again because of what? Because of the refraction of light only. Yeah. There are few numericals that we will do it now. Okay, we will begin with the numericals. A water pond appears to be 2.7, exercise 4C, first question. A water pond appears to be 2.7 meter deep. So this is the apparent depth, 2.7 meter. And the refractive index of water is given to me as 4/3. Actual depth. So real depth I have to find out. So mu W is equal with respect to air is real depth upon apparent depth. So real depth is how much? Apparent depth kitna hai? 2.7 multiplied by 4/3. So 3.6 meter. So real depth is 3.6 meter. Let's quickly go to the second question now. A coin is placed at the bottom of a beaker containing water to a depth of 12 centimeter. By what height the coin appears to be raised when seen from vertically above? So now see what they have asked. A coin is placed at the bottom of a beaker, okay, containing water of refractive index. So refractive index दिया है water का 4/3 with respect to air again, to a depth of 12 centimeter. So real depth is given to me. That is how much? 12 centimeter. Okay. By what height the coin appears to be raised? Appears to be raised means what? That is shift has been asked to us. Okay. Appears to be raised when seen from vertically above. Okay. So appears to be raised बोला है. So shift is asked. So formula क्या है? Shift is equals to real depth into 1 minus 1 upon refractive index of water लेना पड़ेगा. Real depth is 12 to 1 minus 1 upon 4/3. This becomes 3/4. 4 minus 3 upon 4. 3 centimeter. So please read the question carefully. Shift has been asked in this particular question. Third question now. A postage stamp kept below a rectangular glass block of refractive index 1.5. So refractive index of glass is given to me 1.5, again with respect to air. When viewed from vertically above it, it appears to be raised by 7 mm. Raised by 7 mm, shift has been given to me. Okay, shift दिया है मुझे 7 mm. I will convert this into meter, 10 raised to minus 3 meter. Calculate the thickness of the glass slab. Now can you see this? Glass block, sorry. So thickness means what? It will be nothing but the actual depth. Okay. So thickness is asked, which is nothing but real depth has been asked. So never mind, I have a formula. Shift is real depth into 1 minus 1 upon mu. So this 1.5 I will take it as 3/2 now. Why? Because it will be easy for me in the solving the fractions over here. So shift कितना दिया है? 7 into 10 raised to minus 3. Real depth मुझे find out करना है. 1 upon 3/2. So this becomes 2/3. 3 minus 2 upon 1 upon 3. So this goes that side. For real depth is equals to 3 into 7 into 10 raised to minus 3. So 21 mm. So real depth is equals to 21 mm or 2.1 centimeter. You can keep it in any, whichever you want. Okay. So I hope you all have understood this. So with this, C part of the chapter is over. Thank you so much. Yeah, I forgot to tell you all, please subscribe to my channel, do comment, and if you have any doubts, please email it to me. I have the email already, I have already shared with you all. Thank you so much.